Good day everyone, I am Hadassah Paloma, along with my group mates, BONNA NUEVO, ZENITH ORDOÑO, and ALLIN MONDEJAR. We are the group 6 and we are about to tackle another gland found in the endocrine system. But before we proceed, I want you to type or chat in the chat box below an emoticon or emoji that describes how you are feeling today. In this way, we will be able to assess if you are still listening and if you are still able to comprehend today's topic, which is about the parathyroid glands. At the end of this lesson, you're expected to learn what is the parathyroid glands, to know the principal cells of the parathyroid glands, to understand the calcium and phosphate homeostasis, and to identify common parathyroid disorders. So to begin today's topic, let us first know what are parathyroid glands. Parathyroid glands are 4 small ovoid glands in the endocrine system, with each measuring 3 by 6 millimeters with a total of 0.4 grams. It is located in the neck part of the human body, seen in the posterior surface of the thyroid gland. Each small ovoid is contained in a thin capsule from which septa extend into the gland. The parathyroid gland is derived from the embryonic pharyngeal pouches, which are the superior glands, being the 4th pouch, and the inferior glands being the 3rd pouch. So what do parathyroid glands do? Basically, they control the calcium levels in our blood, in our bones, and throughout our body. They release hormones that regulates the calcium levels of our blood, bones, and body. Something noteworthy about this gland is that calcium, being the only element in the human body that has its own regulatory system, which is the parathyroid glands. I've mentioned this a while ago that parathyroid glands have 4 ovoid glands located in the posterior surface of the thyroid glands. But in some rare cases, parathyroid glands can be seen ectopically within the mediastinum and may be seen less than or more than 4. But naturally, we only have 4 parathyroid glands. Take note of that. If you want to ask, what is the relationship? How is parathyroid gland related to the thyroid gland? Well, there is no relationship between the two because thyroid gland controls the body's metabolism while the parathyroid gland controls the body's calcium levels. So there is no relationship between the two aside that they are neighbors in the neck of the human body. So what are the hormones released by the parathyroid glands, and how does it regulate calcium levels, and what are the disorders associated by the parathyroid glands? You will know about that in the next reports. So listen and stay tuned for the next reporters.
I am BONNA NUEVO, and today I am going to discuss the parathyroid principal cells and its function. So, the parathyroid glands have 2 distinct types of cells. The first one is the chief cells, and the second one is the occlusal cells. Parathyroid chief cells, also called parathyroid principal cells, or simply parathyroid cells, are one of the 2 cell types of the parathyroid glands along with occlusal cells. The chief cells are organized as dense cords surrounding the capillaries in the parathyroid. It regulates parathyroid hormone secretion. The chief cells of the parathyroid glands sense the amount of calcium in the blood and release the calcium-increasing hormone parathyroid hormone accordingly to correct or maintain normal blood calcium levels. It therefore regulates calcium metabolism as part of the endocrine system. Parathyroid hormone raises calcium levels by releasing calcium from bone storage, as well as retaining calcium from the urine, and alerts the intestines to absorb more calcium from ingested nutrients. Too much of either hormone can be an indicator of disease. And the chief cells are much more prevalent in the parathyroid gland than the occlusal cells. The next one is the occlusal cells. So occlusal cells are larger than the chief cells and appear to increase in number with age. Occlusal cells are observed either singly or in small groups interspersed between chief cells. They are larger than chief cells, and their abundant cytoplasmic area is filled with numerous large, often bizarre-shaped mitochondria. And it is perceived that occlusal cells may be derived from chief cells at puberty, as they are not present at birth like chief cells. The purpose of these cells is not entirely understood.
Calcium and phosphate homeostasis. Calcium and phosphate are important in human physiology, such as neuromuscular function and skeletal mineralization. The method through which the body maintains proper calcium levels is known as calcium homeostasis. The arrangements in this system results in hypercalcemia or hypocalcemia, both of which can have serious health repercussions. And phosphate homeostasis, on the other hand, is regulated similarly to calcium homeostasis, but not identically. Homeostasis of calcium and phosphorus or phosphate is dependent on a complex, finely controlled system involving several ions and hormones. The effects of these ions and hormones affect calcium and phosphorus or phosphate regulation. The calcium homeostasis. It controls the movement of calcium to and from the bones, and parathyroid hormone controls calcium release from bone. And the release of calcium into the circulation by osteoclasts helps manage calcium homeostasis. The parathyroid gland's job is to keep blood calcium levels stable by producing and releasing parathyroid hormone or PTH. Parathyroid hormone suppresses osteoblast activity while stimulating osteoclast activity in the bone, resulting in bone disintegration in calcium homeostasis. Phosphate homeostasis. Phosphate is employed as a building component for various critical chemicals, including those needed by organism for energy, cell membranes, and DNA. Phosphate is the most abundant anion in the human body. Phosphate is one of the most prevalent minerals in the body, and its serum levels are controlled by a number of complicated mechanisms. Phosphate is also required for the creation of bone and teeth. PTH, or the parathyroid hormone, is a hormone produced by your parathyroid glands that regulates calcium levels in your blood. It is also charged of phosphorus or phosphate and vitamin D levels. When your body produces too much or too little parathyroid hormone, it might induce symptoms associated with elevated blood calcium levels.
Good day everyone, I am ALLIN MONDEJAR and I will be discussing the parathyroid gland disorders and the summary. So there are two identified common medical disorder of parathyroid gland, which is first we have the hypoparathyroidism, a diminished secretion of the parathyroid hormone causing bones to become more mineralized and denser, and striated muscle to exhibit abnormal contractions due to inadequate calcium ion concentrations. Second, we have the hyperparathyroidism, an excessive parathyroid hormone produced that can stimulate osteoclast number and activity, leading to increased level of blood calcium that can be deposited pathologically in our cartilage, arteries, or the kidneys. So to put it simply, it was stated from the previous discussion that parathyroid gland controls and regulates the calcium level in our blood. How? By releasing the parathyroid hormone, which is responsible for putting the calcium level high in the body. Meaning, since hypo means low and hyper means high, then hypoparathyroidism is a result from a decreased secretion of the parathyroid hormone, while the hyperparathyroidism is a result from an increased secretion of the parathyroid hormone. So why does this happen, man? Now let's go back to the calcium homeostasis. So from this picture, again, we can have the acronym, the parathyroid hormone PTH, which means P for puts T, the calcium, H high in the body, meaning that PTH or the parathyroid hormone will be released only by the parathyroid gland when there is a stimulus of low calcium level in the blood of our body. So from the picture here, when there is a low calcium, then a PTH will be released by our parathyroid gland. Then it will be able to stimulate first the release of calcium from our bone. How? By osteoclast, or the breakdown of our bone, or the bone resorption or degradation, and taking some nutrients and bring it back to the bloodstream, specifically the calcium. Then second is to reduce calcium lost in the urine, meaning more calcium will be reabsorbed than be secreted and to be bring back to our bloodstream. And then third is increasing the GI tract absorption of calcium with the help of vitamin D. Then this reaction will help the low calcium level to return to the normal level, which is basically the normal range is 8.6 to 10.3 milligram per deciliter. So to remember it more, for the calcium homeostasis, let's use the mnemonics RIB. So it is from the Simple Nursing YouTube channel. We have R stands for renal reabsorption, I for intestinal absorption with the help again of vitamin D, and B for bone absorption. So it is RIB. So why does I talk about this again? Is because if there is an alteration or changes that will happen from our calcium homeostasis, then of course it will result to disorders. So from that, if there is an increase of the parathyroid hormone released into our blood, causing hyperparathyroidism, it will then cause again for the increased action of the RIB. That will result to, we have this another mnemonics, we have the stone, moans, and groans. Stone stands for kidney stones. So if there will be too much calcium, since there is too much PTH in our blood, it will send a message to our kidney to reabsorb more calcium, and reabsorbing more calcium will result to kidney stones. Then moans for fractured bones. How? From too much osteoclast action, or the breaking down of bone to take calcium, where this breaking down of bone or osteoclast can lead to osteoporosis. And then lastly, we have the groans for constipation of our GI tract, which is by absorbing too much calcium again, causing acidity in our GI tract. So why does our body react like this? Is because again, maybe for the reason that there is a decreased calcium absorption, when our body will have no calcium to be absorbed since we have a low intake of food rich in calcium and vitamin D, or we have an intestinal problem, and of course we have a renal or kidney failure and some tumor problems in our parathyroid gland, causing hyperparathyroidism. Whereas for the hypoparathyroidism, it is mainly caused by the damage directly to our parathyroid gland. Also with hypomagnesium, since magnesium and calcium is closely related to each other. If there is a low calcium, there is also be a low magnesium. And then this magnesium has a role for the secretion of the parathyroid hormone. Or second, when a person had undergone thyroidectomy, a removal of the thyroid gland, and our parathyroid gland lies in our thyroid gland, so it will also be removed. Another reason also is caused by radiation. So thus, along with other glands, this parathyroid gland has a big role for the regulation of calcium in our body by keeping our bones, the beating of our heart, and our clotting factors to maintain its function. So that would be all po for today's discussion and for our group. Thank you for listening, and we hope you've learned something. And if you have questions or clarifications, you can ask us po. Thank you again, and God bless.